All right, hi guys. I told you I'd show my face today, so here I am, and I'm gonna do a little bit of Regents review every day this week for you guys, just to get you ready for the exam next week, Tuesday. So, hi, I'm here. Here we go. So I'm gonna look at this question, and this is number 33 on page 105 in your exam book. So the reason I picked this question to look at is because it's a proof. And these proofs are a little bit tricky, especially when we're talking about proving something like a proportion. So hold on, I'm going bye-bye. I will see you in a minute. Okay, so it says in the given diagram of circle O, tangent E is drawn to diameter AC, chord BC is parallel to secant ADE, and chord AB is drawn. So what I want to do is I want to prove that BC to CA is equal to AB to EC. So really when I see something like this, I know that I need to prove that two triangles are similar first. So first I'm going to try to show that triangle ABC is similar to triangle, let's see, ABC, similar to triangle ECA. ECA. And we prove that triangles are similar by using angle. And so I just kind of want to give you an idea that if you see something like a proportion that you're trying to prove, then you need to be using angle to do that. So I'm going to do statements and reasons. And let's see, my first given is that we have a tangent to diameter AC, tan EC to AC. And then we have two parallel chords. So number 2 is going to be that BC is parallel to ADE. Okay. And let's look at our diagram to see what that gives us. Okay, so if I have EC tangent to AC, then I know over here AC and EC must form right angles. We talked about that before, so I know that this is a right angle. I also know that because angle ABC is inscribed and it opens up to a diameter, that must be a right angle by Thales' theorem. So I know those two things are congruent. So I'm going to work with that first. So number 3 is going to be that angle ACE is right. Okay, so that's this angle I'm talking about. I know that's right because a tangent and a diameter are always perpendicular. A tangent and diameter, or radius, it doesn't really matter, are perpendicular. Okay, so statement number 4 is going to be about this right angle, and we know that's a right angle by Thales' theorem. So we can say angle ABC is right. And for 4, that's Thales' theorem. Okay, so if you remember the name of the theorem, just write the name of the theorem. If you don't remember the name of the theorem, then you can just write that that's a right angle because it's an inscribed angle that opens to a semicircle. So we've got one pair of angles congruent. Actually, we haven't said that they're congruent yet. We're going to do that next. Angle ACE is congruent to angle ABC, and my reason is right angles are congruent. For number 6, we're going to try to get another pair of angles that are congruent. And so let's see what we have over here. So we know that BC is parallel to ADE. BC, that is parallel to ADE, that. So if those are parallel, then we know that these arcs are congruent here. So I can say that arc AB is congruent to arc CD, and parallel chords cut congruent arcs. Parallel chords cut congruent arcs. Okay, so the next thing I'm going to say is that this angle here is congruent to this angle here. And the reason for that is they are both, actually I could have just done alternate interior, or they open up to congruent arcs. So either one. I actually probably didn't need statement number 6, but let's go with 7. I can say angle DAC is congruent to angle BCA. My reason for that would be alternate interior angles are congruent. Okay, let's just try to move this up because I'm running out of space. Oh, I don't want the whole picture. There we go. Okay, so the next thing I'm going to do is I'm going to try to prove, so I can say that the triangles are similar actually. For number 8, I can say triangle ABC is similar to triangle ECA. Sorry, this is so messy. That's going to be angle, angle. So you can see that we have an angle in this triangle, here and here, these right angles congruent, and an angle here congruent to this angle here. So we've got angle, angle congruent to angle, angle. The triangles must be similar. So for number 9, I can set up a proportion with the similar triangles because we know similar triangles form proportional sides. So BC, this would be proportional to this side. CA, BC is to CA, as AB is to EC. And so that's it. BC is to CA, as AB is to EC. And your reason, similar triangles form proportional sides. Okay, so let's see. You get to see my smiling face again. Okay, so that's our proof, and that is on similar triangles with statements and reasons proof. This has come up a couple times. Know for the exam next week, Tuesday, that to do a similar triangle proof, you need to do angle, angle. So if you ever see that you're trying to prove that things are proportional, you're trying to do similar triangles. So I hope to see you at review this afternoon. We'll be doing more statements and reasons proofs this afternoon at review, 3:15 to 4:45. See you then.